In a perfect world, every class would be like this, where you've got a double period. I can introduce this topic and then do a lab on it immediately following it. Because this won't take me more than about 20 minutes to do, and then we'll have the rest of the period and a half to do the lab. All right. So you're going to see what we're actually learning about immediately. And that thing we're going to be learning about is called titration. We kind of had to lead up to this point. We had to talk about neutralization reactions before we got to this. We had to talk about normality before we got to this. And, of course, what an acid and a base really are. All right, we're finally there to do something practical with our acids and bases. You may have done a titration before. You probably didn't call it that. You didn't know it was called a titration. But if you have a pool or a jacuzzi or a hot tub, you have to add different chemicals to that to keep the water from getting moldy, to keep water from having too high or too low a pH, to keep the water from having bacteria grow in it. So you have to add chlorine and other chemicals to the pool. How do you know how much to add? You take some pool water and you test it. You usually test it with, depending on what kind of a kit you have. I know a kit we had when I was growing up was you had to count how many drops of a certain thing it took to turn it color, and then you knew to add one of these two chemicals to the pool. That's a titration. All right, that's exactly what you're going to be doing in lab tomorrow. You have an unknown, and you got somebody you do know. And you can tell the concentration of the unknown by adding some of the guy you do know, concentration of, to it. Okay? So let me show you that. First of all, how we're going to do it. What is a titration? Take a look over here. This is what you're going to have. This is the setup you're going to have. Matter of fact, look back there. There it is. All of those are already set up for you. Okay? These things are called burettes. All right? And this is an Erlenmeyer flask you're going to be using. You reason you use an Erlenmeyer flask because you have to swirl this all the time to make sure it's reacting. All right? Now, let me show you something. When you get back there today, you're going to fill up each of the burettes with the correct stuff. You're going to fill up the acid burette. Matter of fact, it probably has an A that's maybe in red over here, and there's like a B for the base burette. Okay? So if an acid and a base burette, you're going to fill up with the correct stuff. I'll tell you how much later. I'll be the specifics later. All right? So you fill up the acid and the base burette all the way to the top. Okay? So they're filled up. And then you're going to draw off, it doesn't really matter which one, but let's just say, I'm going to just go left to right here. Let's say I open up, this is called a stopcock. You open up the nozzle, all right, it's called a stopcock, and you turn that on, and let's just say you draw off 10 milliliters, okay? You draw off 10 milliliters of the acid. So I have 10 milliliters of the acid, and I know that acid, I'm just going to make up a nice easy number for today, 1.0 molar. Now, you add that into your Erlenmeyer flask, and then you add an indicator. The indicator you're going to use today is one you've used once before. It's the one that turns either pink or clear. Remember that one? He's called phenolphthalein. You remember you were using them? Use them in those reaction wells when we were doing those white powders back there. Okay. So now you've added your 10 milliliters of acid into an Erlenmeyer flask. You add in your indicator, and you move it over to the other side. Now, I then add my base slowly. As I'm adding my base, I watch what happens to the color. And when it finally turns color, I know to stop. That's when it's neutral. Okay, it's neutralized. Let's say the amount of base is exactly the same as the amount of acid. Let's just say it takes 10 milliliters of the base to neutralize 10 milliliters of the acid. The acid was 1 molar. What must the concentration of the base be? 1, the same. Must be the same, right? All right. Let's say it takes more base. I have to go down to, say, 20 milliliters. I have to keep going. It just keeps going and going and going, right? What about that? What's the concentration of the base? If it takes 20 milliliters of the base to neutralize 10 milliliters of the acid. 0.5, right? Doesn't that make sense? Right? It took more of this to neutralize less of that. This guy must be stronger. And if the factor by which he is stronger, if it took 20 milliliters of this, would be twice as strong if it took 10 of that. That all makes sense? That's the whole logic behind it. So you'll know how strong your acid or your base is based on the one that you do know, and the unknown you figure out by how much of it took to neutralize that guy. That's the whole point behind a titration. Okay? It's basically a process in which a solution of known concentration is added to an unknown to determine the unknown's concentration. Now, the logic behind it I just went through. The equation behind it is very familiar and very easy, as you'll see. There are 4 variables in this equation, as you probably figured out already. What do you think the 4 variables are going to be? There's really 2 variables if you think about it. There's what I'm looking at these 2.
Acid.
The what of the acid? The volume. How much? So the volume of the acid and the volume of the base are 2 variables. And what else? Yeah, the molarity or the concentration of the acid and the concentration of the base. Actually, it turns out, remember I told you a little while ago, we had to have done yesterday's class before this. What might have made a problem with this if I use molarity? What should I probably use? Normality. That takes into account how many H's or OH's, and that's what I will use. So the equation is NaVA equals NbVb. Na and Nb probably stand for what? Normality of the acid, normality of the base. Va and Vb would stand for the volume of the acid and the volume of the base. All right, and by the way, I told you it would be very easy. I also told you it looked familiar. What does it kind of look like?
M1V1.
Yeah, it's almost exactly the same as M1V1 equals M2V2, the dilution calculation formula. All right. Now, this is real easy to use. That's all the notes I have. I'm going to do 2 examples on the board for you, and then we're going to go back in the lab and do it. This lab is going to be different from the previous labs we've done, as you'll see in a little bit. But let's get through the notes first. Applying this equation every time, one of these variables will be the unknown. Okay? Usually it's the concentration we're trying to find out. Okay? Let's do this first one. Find a normality of the base, and I tell you the concentration of the acid, and I tell you the volumes that you needed.
You could ultimately give us the molarity of it.
I'm going to, in the second example, I'm going to throw every curveball at you in the second example. The first one I made pretty easy. But even in the first one, you have to read. I mean, this is a classic example of a problem where you are going to want to write down the given information to the side, do the algebra, plug your numbers in, like I showed you going way back to D equals M over V, the density problem. Okay, classic example of how we do. And we've seen this throughout the year. How many times have we seen this? PV equals nRT, V2, P2, T2. All right, delta H equals MC delta T. All of those places and more. We've seen and we've done it this way. Only very short things or conversions do I not write the stuff down to the side. Whenever I have any length of a formula or an equation, I want to do this so I don't get confused. What's Na? What's Va? What's NB? What's VB? I want to make sure I read the question and pick that out because I did have problems in the other class finding the right ones in this one and the next one. Let's see. Read. What do you think Na is in this first problem? Raise your hand. The normality of the acid. What do you think the normality of the acid is in this first problem? Raise your hand. Everybody looking? Some people may have trouble because they say, nowhere up there do you see the word normality. All right, actually, except for finding the normality of the base. You don't see an N or normality. So you might be thinking, it didn't give it to me. But it did, just not directly. But what did they tell? What does it give me that I could use? Yeah, it gives me the 0.40 molarity. And by the way, I actually got this question, believe it or not today, but I've gotten it many times. Well, how do you know if H2SO4 is the acid or the base? Seriously, at this point, I actually got that question. All right. Obviously, he's the acid. So that's why it's Na and not Nb. All right, but here's the problem. Because that's 0.4 molar, I have to take into account how many H's or OH's it has. And it has 2. So I multiply by 2 and I get 0.80 normal. Now, Va is the volume of the acid. Which is the volume of the acid, Jared?
10.0 milliliters.
10.0 milliliters. Good. The normality of the base. Ellie, what's the normality of the base? Yeah, find the normality of the base. It doesn't get any easier than that. It doesn't get any more blatant than that. Nikki, what about the volume of the base?
12.
Yeah, it has to be 12.0 milliliters. Now, I made this one pretty easy. Okay? NaVA equals NbVb. I have to solve for Nb, so what will I do to both sides? I'll divide both sides by Vb. You know, if nothing else, people, throughout the year, I'm hoping you got pretty good at doing some basic, simple algebra that will help you anywhere doing any kind of an equation in math class or in SATs or whatever. All right, so I have Nb equals NaVA over Vb. I mean, this is pretty basic algebra. Plug my numbers in. The normality of the acid is 0.80 normal. The volume of the acid is 10.0 milliliters. The volume of the base is 12.0 milliliters. Do your math, what do you get? Mark, what do you get?
0.67.
Correct, and he rounded it off correctly as well. Milliliters cancel, 0.67 normal would be the correct answer. That's the normality of the base. You actually get 0.666 repeating. Okay, but that's 0.67 rounded off. All right, very good. Now that's about, that's not even, I wouldn't call it the easiest possible problem, but it's pretty easy. This next one, I threw in quite a few other curves at you. Take a look at that one. Copy it down. Like I said, most of the time we are looking for the molarity or the normality of something, the concentration. It's possible some of the homework problems and on a test I could ask you to solve for a VA or a VB to volume. But practically speaking, most of the time you're looking for the concentration of the unknown. All right, now you'll see, although I'm going to do this one exactly the same way as the other one, it's going to have some twists to it that I have to watch out for. Na, Va, Nb, Vb. First off, normality of the acid. Well, what do you think about that, Josh? Exactly, it's the unknown. Find the molarity of phosphoric acid, which basically you say, well, that says molarity, not normality. Remember, normality and molarity are related. We know how. We'll cross that bridge when we get to it. For right now, it's the unknown. What's the VA here, Rebecca?
20.0 milliliters.
Everybody agree it's 20.0 milliliters? Again, that one doesn't get any easier. 20 milliliters of the acid. You kind of know that's the volume of the acid. Normality of the base. Ben, what's the normality of the base? 2.1 molar. And is that correct?
No, it's 4.2.
Yeah, what do I have to do with that? Right, I have to multiply it by 2 because I've got a base that has a subscript of 2 around the OH, so that's times 2 gives me 4.2 normal. And finally, the volume of the base is what, Zach?
48.0 milliliters.
48.0. Well, let's see. Let's put down what they have, what it gives me in the problem first. It gives me in the problem 0.048 liters, right? And I wanted to do this because I want you to realize that here's liters here and there's milliliters there using the same, measuring the same thing. They have different units, can't have that. So I'll convert him to milliliters. There's the bottom, milliliters on the top, 1,000 milliliters for 1 liter. And I get 48 milliliters. Not 48.0 because he has 2 significant figures and he has 2 significant figures. Okay. All right. Can't create them by just converting. All right, there we go. So I've found a couple of problems again. Normality in here, liters, milliliters, units there, and the biggest problems yet to come. And there's a mistake that people make on that big problem that's yet to come. Okay, NAVA equals NBVB. I'm solving this time for NA, so I'll divide both sides by VA. So NA equals NBVB over VA. NB is 4.2 normal. VB is 48 milliliters over VA, which is 20 milliliters. Do the math, what do you get? Significant figures wise, it can only have 2. He's only got 2, he's only got 2, so what would he be significant figures wise? What? Is it 10? Yeah, you can either write 10 with a decimal point, that would be 2 significant figures, or 10 with a bar over, either one would be correct, but most people would put 10 decimal point to be correct. All right, am I done?
No.
No, that's the normality. That's the normality. However, the question wanted molarity. All right, now I know I'm going to get this as a mistake. First of all, I want you to realize something. Had that acid been HCl, and that's the normality, what would the molarity be? Same exact number, right? But he's not. He's phosphoric acid. Phosphoric acid is H with a +1, PO4. He's on the sheet with a -3, H3PO4. So I'm going to multiply by 3, right? Divide by 3. But I know people will multiply. I'm not going to multiply by 3. I'm not going from molarity to normality. I have a normality. I'm going from normality to molarity. I divide by 3, and I get 3.3 molar. Because remember, it's the molarity times number of equivalents that gives you the normality. All right. Now, I want you to copy down this homework right now, but then I'm going to start in the lab. Okay. There's the homework. I want to start into the lab. While you're copying that down, let me say a few things about this lab. I said a little while ago, this is not a typical lab. Reason? I don't have a lab paper for you. 90% of the lab, 99% of the labs you have look like, here's one from Chem 1, I'm sorry, Chem 2, and here's one from you guys. You know, they're basically cookbook. They give you the procedure, the data tables. You just have to fill it in and then do the calculations. Here's your lab paper for today. That's it. All right, you're going to do your own. I'll show you how.